In this video, we take a look at Arnold Denoiser. Let's go to the render settings and open up the Denoiser tab. Now, this is a post-render denoiser unlike optics. After your render is finished, you define that EXR file as your input, define where you want the output to be saved, adjust the denoising settings using these variants, pixel search radius and pixel patch radius, click on denoise and Arnold will denoise your render and saves it out. At the time being, Arnold Denoiser can only denoise the beauty AOV and the light group AOVs. As far as I know, I don't think you can denoise other AOVs. And it can also work with multiple frames. Let's take it step by step. First of all, how much can you rely on denoising? Because I've seen people who use a very low sample counts and think that they can get away with it and make their render clean with denoising. I would say that is not what denoising is for. You really can't do that, as the final denoised image would have splotches and artifacts and the result would not be production approved. In my experience, you can rely on denoising to take out the last 3 to 4% of the remaining high frequency noise, which especially in interior shots will be almost impossible to get rid of unless you use very high sample counts and wait countless hours for your render to be finished. Let me show you an example. On the left side, we have an interior render from the interior lighting lesson without denoising. And on the right side, we have the denoised version of the same render. So the original render maintains this high frequency noise, which is really hard to get rid of. And on the right side, we simply put that render through Arnold Denoiser and we get an absolutely spotless, clean render. Now that's the type of noise that Denoiser is designed for. So you cannot expect to put a shitty, low quality and horribly noisy render through Denoiser and get a perfectly clean render. If you are planning to put your final render through denoising, you need to take a few things into account before pressing the render button. You need to make sure the EXR driver that outputs your render has the proper data that is required for denoising. And to assure that, if you go to the Arnold menu and come down to the drivers, there is this EXR driver for Arnold Denoiser which has the proper settings built in. Also, if you open up this input section under the Denoiser tab, you have this Create EXR Driver button, which does the same thing. So let's create an EXR driver for Arnold Denoiser from the Arnold menu. If you check out the driver, it looks like a regular EXR driver, and it is. To make an EXR driver compatible for denoising, just make sure to enable merge AOVs and output Arnold Denoiser AOVs. If you check these two options and render your scene, you can use that saved out EXR file as the input for Arnold Denoiser. Let's click on the setup AOV and select the beauty pass, and let's enable all the AOV light groups for it. And let's save it out in this deleted folder on my desktop and name it something like final render. If I go to my render settings and take a look at my sample counts, you notice they are fairly low, which is not proper for denoising, as I mentioned, as the final render will be too noisy for denoising to make it perfectly clean, and the final denoised image will be a bit splotchy. But to show you some of the settings of the Arnold Denoiser, I need to use lower sampling rates. All is good for now. Now we can press the render button and wait for it. Now the render is finished, and as we are using ACES, the render looks bad in the picture viewer, but that is okay. Now we can start denoising it. Let's load that rendered EXR file in the input field of the Arnold Denoiser. The output field is automatically filled out, and it is simply puts a denoised suffix at the end of the string. Now, instead of a single frame, if you wanted to denoise a sequence of frames, simply load the first frame in the input field, and Arnold will load all the sequence and set the output field to denoise the entire sequence. And you can use the frame range settings down here to denoise the entire sequence or only a certain frame range. Now, because we only have a single frame, these options are grayed out, but if you load a sequence, they will become available. So we are ready to start denoising, but if you remember, we also had some light group AOVs for the beauty AOV. To make sure those AOVs get denoised as well, you can use this light group AOVs field. You can open it up and use this read light group AOVs, and it will take a few seconds. And now it added all those light group AOVs and they will be denoised when we hit this denoise button. Now, before doing that, you can go ahead and adjust the variance, pixel search radius, and pixel patch radius. We talk about them in a moment. And then click on the denoise button. It normally takes a few seconds per frame, but as we are denoising not only our beauty AOV, but 5 light group AOVs as well, it will take a bit longer. And now denoising is finished and we can view the denoised image in the picture viewer and compare it to the original render. Now let's do a proper comparison in Fusion. Let me load the final render and the final render denoised into the Fusion. Add one of the existing OCIO color spaces, which turns ACES CG to sRGB color space. I'm going to load the original version in the left view and the denoised version in the right view. And you can see we get a much cleaner render. Because the original render has a bit too much noise, the denoised image is not perfect and we get some splotchiness under the couch, for example. If the original render was more clean and we used higher sampling rates, the denoised image would have been perfect. After the denoising process is finished and you are not quite happy with the results, let's say, you can simply open up the Denoiser tab, change the variance, pixel search radius, or pixel patch radius, and click on denoise again to get a new denoised image based on the adjusted settings. Now let's talk about these settings and let's start with variance. Now variance is the denoising amount. Higher values will remove more noise, but that can result in some detail loss. 0.25 is a good low value, 0.5, which is the default value, is a medium value, and 0.75 is a high value. Let's come back to Fusion and load this denoised render with variance set to 0.25 in the left view, and the second one with variance set to 1 in the right view. You can see when the variance is set to 1, we clearly get an overall cleaner render, but we have lost some details. If you take a look at this plant shadows, for example, and the default value of 0.5 is good in most cases. Next, we have this pixel search radius. When denoising is performed for a specific pixel in the image, Arnold will look for a square area around that pixel, and the pixel search radius specifies that search area. The higher the search area, the better the result. If I get back to the Fusion, let me load this denoised image with pixel search radius set to 3 in the left view, and this other one with pixel search radius set to 9 in the right view. And you can see with lower pixel search radius, we get a lot of splotchiness without any extra detail preserved. But with higher pixel search radius, we keep the detail but get rid of some of that splotchiness. Let me load the image with pixel search radius of 9 in the left view and load this image with pixel search radius of 18 in the right view. And if you compare the two specifically under the couch, you notice we get cleaner overall image with less splotchiness without compromising that much on details. So that is really important. As you can see, increasing the pixel search radius will result in an overall better denoised image, and the penalty would be the longer denoising time, which is acceptable in most cases. And finally, we have the pixel patch radius, which is a bit hard to explain really, but it increases the softness of the denoising, especially for the higher frequency noise. The default value of 3 is usually good, a low value can be 1, and a high value is about 5, but keep it as its default state in most cases. Let's come back to the Fusion and load this denoised image with pixel radius of 1 in the left view, and the other one with the pixel patch radius of 5 in the right view. If you take a look under the couch again, you notice that increasing the pixel patch radius will result in less high frequency noise, but it does not affect the low frequency noise or the splotchiness that much. If you go too high, you can lose some intricate detail in your render. Usually I leave it at the default value of 3. Okay, so that's about Arnold Denoiser. See you in the next video.